and this is Michelle, and today I want to share something about regular expression with you. And I suppose you all know something about it, so let's begin. First is introduction. A regular expression, often called a pattern, is an expression used to specify a set of strings required for a particular purpose. A simple way to specify a finite set of strings is to list its elements or members. I know you all have no what's regular expression, so just let's go through it. Here are some tables about mental characters, which is the basic conceptions in regular expression. Since it's not direct feeling and not easy to understand this just by seeing these tables, I will introduce them in a website. And thanks Duty to provide the powerful website. And you can see here is reference. We can take it as a tutorial of regular expression, and it's convenient. The first is you can see the explanations here and examples, so it's clear it's easy to learn. The first is dot. You can see it matches all the characters here. The explanations is match any character except line breaks. Line breaks include line feed, 回车, and carriage return, 换行. So any character except line breaks, dot. It's match any, or let's skip it. The third is word, is backslash with uppercase W. It's equivalent to letters, no matter what uppercase or lowercase, and numbers and underline can see here. Can see it matches any characters except this special characters. It's word, and the backslash with uppercase W is just the opposite of the word. It means not the letters, not numbers, and not digitals. You can see it matches the rest. And the next is digital, backslash with lowercase d. It's easy. It's just the numbers 0 to 9 and not digitals. It's web space. Can check. It matches any space. Not web space. Character set. It's square bracket, 方括号. The square bracket means a set. It means it will match the characters in this square bracket. The A, E, I, O, U. It will all match. The next is the carried. 这个倒三角符号 carried, and it means not. Okay, you can see it matches any characters but not A, E, I, O, U. And the range, it's simple, it's just hyphen, means it can match G to S. You can see the examples here. These are very basic conceptions. I hope you can remember this dot, word, digit, and white space. And anchors, beginning, end. It's just I just can see it can match the very first W. From my knowledge, I guess it just can match the very first character in one line. If I put this, I can match the E in the third line too. But if I want match B, because there's no B in the very first character, so it won't match. So this beginning and end just means the very first character in one line and the last character in one line. I can take it. You can see everything just in the last of the line. And it's what boundary. I can give example if I want make is happy by PP can match. But if I add a word boundary, oh sorry. So it can't. It means before PP it can disappear any characters. And the how can I explain it? Word boundary means the left of the PP can there's no characters, okay, and it's not word boundary. It escaped characters 转义字符 and it's simple. Just you can see the dot. You can see the dot. It means any character. But if you want to use what it is, just a dot, you may need to make it escaped. If you make just a dot, it will match any character. Okay, it's simple. I won't use more. And next are very important. It's caption group. Take it. HA. It takes HA as a group. I just delete the plus. It's you can see the words in the black box. You can see group 1 is HA. Can you see? I can move into it. You can see group 1 HA, and if I need more, see group 2 is PP, and I can add more. And now it changed. Group 1 is HAPP, group 2 is HA, group 3 is PP. The order of the group depends on the left brackets. The order of the left brackets. This is the first left bracket. So the whole string, this whole regular expression is group 1, and this is the second left bracket. So this is group 2, and this is group 3, and it's not difficult. And next is back reference. Match the results of previous capture group. You can see here. I give it. It just cites the group. It cites the group 1. You can see HAPP. This is the group 1 HAPP, and this is just the same as group 1, the second HAPP. If I need here 2, I want. Can someone tell me what strings should I add? And it can match. This is the first. The whole group is the first group, and this is the group 2, and this the position just the group 2, and we need to put the group 2 into this position. So, what characters should I put in this position? Sure. Yeah, the answer is HA. Thanks, Terry. The next are, I won't introduce the next. If you are interested, you can learn for yourself. And it's also important part. First is, I will introduce this first. It's quantify 量词. It means match the least time. and the right three means match the most time. It can match one time, two times, and three times. Give it. I won't do this. I just give it a. So it can match. It can match two times and three times. The least time and the most time. And it's simple. The plus means match one time or whatever time. So in fact, the plus just means one time and whatever time you want.
No less than one time, right?
It's the least time, and you can match whatever time you want. It's the endless means. The first is stop and match their time or whatever time you want. It just means it's equal to this, and it's optional. The question mark match zero time or one time, so it's equivalent. It's simple and simple. And what I want to mention is that these three quantifiers are greedy by default. The greedy means they will match most time as they can. You see, it has three times. It won't match only two times. So since it's the most time, they will try their best to match the most time. Okay. And this question mark means lazy. If you add one question mark in these three quantifiers, it changed its mode. Means it will match at least time as it can. You can see here. So it will just you see, it has three haha, but it will just match two, because you add a question here. And next is alternative, means it's simple. It's just here. BAD, BD, BID. It's the option, just whatever you want. The option. And the next is substitution. I will just introduce this. Okay, just take it as example. I don't like this. So just give it. Oh, sorry. Give it one, and this is group one. But the match results. There are three match results. So the list won't have three. Group one. In this, see the group one is A, group one is E, I. And I can take it more. Word. And then match all. And I can tell this dollar at one means group one. And I can do more. I can't.
Don't have the second group?
Yeah, it means second group. Why? I mean this answer. First one is okay, so our first can't work. Oh, sorry, I didn't give it a group. Stupid me. See, it's group one, it's group two. It's not difficult, right? And this, I won't introduce this often. Let's go back to our PPT. Tables are here. And sorry. And if just have one number, it means matched exactly n times. Okay. Okay, the next is testing, but it's not real testing. I won't ask your answers. The first is, and this question is also the reason why I choose regular expression as my case topic. Because one time in Sanofi campaign, I need to complete the image tag, and there are so many images, and I resort to regular expression. So, does anyone have any idea about it? Okay, the first step is to find the position that the slash should put in. I'll just give the answer. See, this image, find image tag, and it means any character, right? And it means lazy pattern. It will match at least time as it can. And this is the last end tag. And replace with $1 the first group. We can put here. It's the third-party code in Sanofi campaign, and you can take any picture, and it's the image tag is not complete. See here. So we just can find the image here. Here. Yes, we can find. Sorry. Oh, what happened? Oh, I know. Sorry. We should use regular expression. Then we find the image tag. And just $1 with the backslash. Place all. See, all the images have completed, and I think it's useful in our daily work.
What if we have some slash? We've already have some slash in some of the image tag. So how can you exclude that slash tag and make sure all the wrong image tag are fixed?
Remove it, yeah. Replace all first and then replace the one with two.
If I will delete the slash first and then replace it all. I will find if it has slash, if it has the delete, and add the slash. Okay. And it's another way, just the same result. Find the character not this end tag, and its Grady pattern. They're the same. Oh, sorry. Here should be an end tag. Sorry. And sorry, why? Okay. It's the screen's question, not mine. This is optional question. Can someone give me answer? It's words, letters, digitals, underline, and the backslash with Z is a number. Can you give me answer? You see, it's word, number, and the full question. The very first is E13. So this is E, this is 1, this is 3. So can you give me the answer of it? It's not very difficult, I see. I think. Okay, I'll give you more time. Azure, do you know the answer?
I've answered you twice. Is the answer A?
Yes, the answer is just A. You can see this is the first left bracket, so this whole bracket is group 1, and this group 2, and this group 3, and group 4. So E13 is group 1, and it repeat one time, and the group 2 is this 2 and this group 2 and whatever the word. So the answer is A. So does anyone have any problems?
No.
No. And sorry, I give the answer. It's also a question. I want you to write a regular expression to which can match integer, whatever positive or negative. So does anyone have an idea? and the number is backslash with B. And I'll give water and give it here. And give some numbers. Please match them. So, and I have an idea. Okay. Just because this just numbers. So the first is, of course, should be a number, and integer should have several numbers. And so I will give it I will give this. It's more clear. It should appear at least one time, so it's a integer, it's a number, okay? And there is a negative character, so I will give it a negative character. Means it can match one time, or 0 time. It cannot show. So, and this answer should be easy, right, and match all of them. But the question is, if I put 90 here, it will match, but it's not an integer. So, do you have an idea to improve this? Woody, do you have any ideas?
Zero, a character 0 before the D, after the question mark.
Yes. And my answer is just 29, except 0. And I give this just whatever it wants, and I will just add 10. So it's my final answer, okay? And it's an easy one. The next maybe difficult, okay? I want to integer or decimal numbers, okay? Because I think it's difficult, I will just give out answers. And it's long enough. It's very long, so I will just explain why is this. Let's just take about decimal number. Decimal number. You see, let's take it here. Give some decimal number. Right. And give the apparently it has a dot in the middle of the numbers. So number dot number and several can appear much time, right? Match at least one time. Sorry. And right, and it matches all, but appeared clearly it should not be matched, right? And the result is the same. It has two conditions. Once the first character is 0 or not, so I will give it. So we'll just delete it first. It should 1 to 9 and digits, and here, or we give it a 0. Right. And also, yeah. So it matches its decimal number. And we need to add integer. The most easy way is to give it a bracket and use a or. The last answer is what? Let me see. 1 to 9 and digitals. 0. And 0. So all of them have matched. It's the easy way, and you can put them together, and together it's the final answer. So it's a little bit long, so just go through it. It's scientific notation, 科学计数法。And I will just give up the answer. You can see it's just in 1 to 9. It's just a number, right? It's just a number. And it's E means the power of time. Can I explain here in Chinese? I can't.
Power of time is clear.
The E means mean. 因为科学计数法是10的多少次 mean， 这个1就表示它的 mean， and the next is the mean 的次方的那个数字，前面是它那个，就是科学计数法一般都是几点几乘以10的多少次 mean，so the here is the first number and it's the power number, okay, and this E or E must appears at least exactly one time. Okay, the next is greedy matching and lazy matching. As I mentioned before, these three quantifiers are greedy by default. They will match as many characters as possible. And once you add a question mark after these three quantifiers, it becomes lazy matching. Its example. Here is a string. If you use this to match, it will match all the string. It will match the last quotation. And lazy matching, it will just match the second. Okay. And I will take regex as an example to explain why. In greedy matching, in greedy matching, the first quotation matches this first one is easy, and the continuous goes to the dot, and the plus character makes the dot greedy, so it just will match, and yes, the last quotation will match. In this step, the dot will match regex and the quotation. And now it can match because there's not other characters. And now the dot gives the contour to the quotation. The quotation tries to match, but there are not any other characters for him to match. So the quotation asks the dot to speed out the character, and the dot will speed out the last quotation and to let this quotation to match. And it tries to match. Yes, okay. So the whole pass ends. So it will just goes back. Contour goes back. The process just appears once. And in lazy matching, the first quotation matched, okay, and the dot tries to match, but the question forced the dot lazy. So this star means match 0 time or whatever time you want. So you just match 0 time, okay? So where's my mouse? The dot tries to match. It's lazy. Just don't want to match. Yeah, it doesn't match, and it gives the contour to the quotation. The quotation match this R. Oh, this not match. So the contour goes back to the dot. The dot forced to match the R, and the next goes to E. The dot tries to match E, but it tries this time is 0 time. It not match too, and the contour goes to the quotation, and the process repeated so to the last. Since my English is poor, I guess all of you are not get my point, so I will explain it in Chinese again. 这个贪婪模式的时候，一开始这个引号跟它匹配是可以匹配的，然后这个时候这个点 and character 它开始匹配，因为后面是贪婪匹配，它是能匹配多少就匹配多少，它会一直匹配到最后一个这个引号，就匹配到最后一个，然后它不能再匹配了，后面没有任何字符串了，然后它把控制权交给后面这个引号让它匹配，但这引号已经没有字符让它匹配了，所以这个引号强制前面的这个点让它吐出一个字来让它匹配，所以这个句号吐出了一个字让它匹配，它正好匹配上，那就结束了。如果这后面加一个 A 的话，这个句号会匹配到这个 A， 然后它会吐出这个 A 来，让它和最后一个引号来匹配，不匹配的话继续往前吐。然后就是说gradient matching 的话就是一直往前吐，然后 lazy matching 它就一直往后吐。你看这个匹配好之后，它是因为这个是匹配0次或者任意多次，它开始匹配的时候它不会匹配，因为它很懒，然后它就把控制权交给了后面的引号，然后引号开始匹配，但匹配不上，所以控制权回到这个点上开始强制它匹配，然后到下面一个它又不愿意匹配，然后就是这种过程反复直到最后一个。So the key of efficiency is backtracking. The process of speeding out the character calls backtracking. Backtracking is the efficiency of the regular expression. It depends on backtracking it clearly, and we can optimization is we made optional between the gradient matching. You see, not the quotation and hero match. So strictly, it's no backtracking. It will create one, just like the process of this. So have you know the backtracking I know all of you have known. So that's all.
All of you, did all of you understand which one is the most efficient one between the greedy and the lazy matching? Anyone has the answer?
Yeah. Can anyone answer the question, which one is more efficient?
First one, really.
Yeah, yes. There's no answer. Right. Good.
Yeah, if you go back to previous logic, thinking of you are a programmer, for the lazy matching, you may have maybe 5 or more line of code. So greedy is the most efficient one. But if you are doing some programming work, you should try the the simplest one. Maybe it is the lazy matching, maybe it's the greedy matching. Only optimize it when you are meeting some efficiency challenge. Only in that case you can try to optimize it. But in normal case, the lazy matching is not that slow. It is almost the same as the greedy. Okay.
Okay.
Okay.